part of this today for the final and what we expect to be the absolute best Mantis webinar plan for the end of this year. Our focus today is on a component of our industry-leading DC Expert application, and that component is labor benchmarking. I'm Doug Bailey. I'm the Mantis North America Business Development Manager, and I'm joined today by a couple people from our team. Adi Ng, who's our Mantis Customer Success Manager, and the man of the hour, that's Lee Rector. He's our Mantis North America Executive Vice President and founder of DC Expert, what we consider a DC expert in the application. And he's going to really lead us through what we're going to dig into today. Just a couple housekeeping items before we get started. We may not go the full hour, and everyone's on mute. If you have questions, please feel free to use the Zoom Q&A feature, and we're going to attempt to address these as we go or at the very end of our session. And now I'm going to turn things over to Lee.
Good afternoon, everyone. Thanks for your time and joining us today. What we wanted to do today was to give you a little bit of insight, excuse the pun, into labor planning and labor benchmarking, kind of the who, what, hows of labor benchmarking, and then how you might apply it within your operation. And then once applied, how does that actually help you drive out savings within the operation, whether you're a consultant, you're a 3PL, you're a wholesaler, manufacturer, doesn't really matter. The theory that we're going to give you here today is applicable across all operations. So what we'll do is we'll talk a little about why benchmark, then what aspects of the operation should we benchmark, then how you can do it. And then we'll just talk a little bit about our DC Expert benchmark and what's involved in that. And if we have time, we'll give you a 5-minute demonstration on our package. So why benchmark? There's an old adage out there that if you can't measure it, you can't manage it. We see that all over the world where companies are not managing their businesses right because they actually don't know their own data. Understanding your own data and what to look inside your own data is the first step in figuring out whether or not we're actually an effective operation. Why do we want to benchmark? Well, if we take a look at our general rules of thumb for an operation, if we take a look at the overall spend of an operation, so for every dollar that we spend, about 50% of that is spent on labor. So it's still by far the largest spend that we have in any operation. So we want to focus in on that, and then the aspects of labor that we have, how can we actually optimize those and track those? So that's we'll call it the subset, the underlying theory that we're using to drive out changes. Now, automation tends to skew these rules of thumb slightly, but at the same time, whether you're in Amazon that still has 800 or 900 people inside of your operation and $50 million worth of automation, you still have the people, and you'll still have each aspect of these general rules of thumb inside the business. They just might be slightly less in certain areas. So really, where we start with is what we'll call the activity work paradigm. We've all seen this where you go out on the floor on Monday, we do 8,000 cases. And then on Wednesday, it's our peak day. We go out and we do 12,000 cases. And then on Friday, again, we go back down. It might be 6,000, 7,000 cases on that Friday. But what happens is you're the manager of your operation or you're a supervisor. You look out on the floor and everybody's busy. So what happens is there's this collective collusion inside of operations that we actually try to eliminate. So what happens is on Monday, they know it's an average day. They work at a regular speed. On Wednesday, they know it's going to be a busy day. They don't want to spend more than a couple hours worth of overtime there. There's a football game, a hockey game on, or something like that. So they actually work faster. And then on Friday, what happens is they tend to work slower because they don't want to get sent home early at 2 o'clock in the afternoon. They want to collect their extra 3 hours. So they collectively slow down. They do things like make work projects. So they slow down, they start picking up doing maintenance, they start doing house cleaning, and all of these things affect the way we run our operation. What we typically want to do is we want to benchmark the activity level, as we see here in this top line. where we say anything above that line is what we'll call stress on the operation. So that's more than what we've bargained for or that we've planned for. And we can either hire temporary or we use overtime to address that stress on the operation. But when you look at maybe a Tuesday or a Monday, anything under that line is underutilization inside of the operation. And what we want to do is we want to manage out that underutilized time. We can't design out underutilized time and such, because this is actually a function of management. It's not a function of design or automation. So what we want to do is we want to get away from the mirroring of the work activity paradigm. The other piece of the pie that we want to look at is our personal fatigue. Now, a typical personal fatigue curve, we look at not only time, but we also look at temperature band. So when people are working in a superheated or a refrigerated operation, what happens is the personal fatigue curve shifts to the left. Okay, so what you see then is us hitting our maximum throughput at an earlier part of the day. Where you see the big issue with overtime is that we have a huge drop off between 8 hours and 10 hours. So we're paying time and a half for actually effectively about 82% at the max of our labor. So we're paying more for less. So what we want to do is take that into account when we're building out our KPIs, so that when we go back to our curve that talks about stress, what is the best way to handle that stress? We want to minimize overtime by having a better plan. Then lastly, when we start talking about benchmarking, why do we want to benchmark? What are the benefits of that? Well, when we set defined standards for our qualified FTEs, so that's not somebody who's just started today, but somebody who's maybe been working in the operation for 15 to 30 days, we can then track their productivity. Whether you're an operation that's looking at some sort of incentive type basis, or you're working towards an LMS, labor management system, where you're looking to 100% utilization, it doesn't really matter. But having that defined set allows me to do better planning within the operation. We can then manage out those underutilized hours based on the workload that's set for each activity. Now, activities could be varied across the operation. By having a benchmark for our standards, we can then illustrate or measure performance of a shift against a shift. We can measure shifts against each other, or an operation from one operation to another. And we want to take out sort of the noise where one operator will say, oh, well, they've got all the easy orders and we've got all the hard orders, or we've got the bad SKUs and they've got the good SKUs. And what we want to do is we want to take out all that to say, okay, we're all looking at the same data and we're all looking at the same operation. So looking at things just like case activity doesn't really effectively illustrate the performance of an operation. Not only that, when we look at these benchmarks, we can see, oh, that I'm at a certain rate for picking and I have a much lower rate for receiving, so that I might have an opportunity in receiving to increase that productivity. So these define the opportunities within the operation. One of the most important factors that I see in the market today is the ability to predict what's going to happen if I make a change. So I'm going to add new racking, or I'm going to add automation, or I'm bringing in a new manager, or we're spending money on new IT. It doesn't really matter. We want to have hard, concrete numbers that we can measure from before the change to after the change. But what we don't want to do is make the change without knowing what an expected result is going to be. And then, of course, once we've done that, we want to be able to measure the cost based on that change. At the same time, we might want to then look down or drill down and look at a subset of the operation and say, oh, how much is it costing me to put a Walmart order out versus a small family-owned operation in maybe a remote area, because those costs of service would be very different. Or if we have a set of A SKUs versus our slow mover SKUs, we'd want to build up a paradigm on that that shows me what my costs are effectively by each subset. And then lastly, the most important part of this, it eliminates the natural collusion of the operation to speed up and slow down with the ebb and flows of activity. So we could go into hundreds of benefits or individual benefits or subcategories of this, but this is really just a highlight of why we want to do benchmarking. What we see is operations that don't have benchmarks have typically a higher amount of overtime, a greater amount of errors, and a lot of underutilization in the operation. Companies like this that would hire to the employee. And what I mean by that is they hire 15 headcount, not based on workload, but we need 15 people. And we have 15 people on Monday, and we have 15 people on Friday. And on Wednesday, we have 15 people, but they all work 4% or 4 hours overtime on Wednesday, regardless of the ebb and flow of the operation. When we make changes in the design, in the management, in the technology, even the slotting of the operation, we don't get the expected results. So what happens is we expect a greater degree of productivity, and really what happens is it doesn't show on the floor. And what that tells us is that we've actually made the work or the job easier, the performance level easier for those people working on the floor, because we're not managing out the hours that we expected to receive through that productivity design. Typically, what you see in operations with no benchmarks is they run as a street gang mentality. And what I mean by that is they work at the speed of the slowest person to protect everybody within the group. So if they have somebody that works slow, they'll say, hey, Johnny over there, slow down. You're making everybody look bad. We have to slow down or we have to speed up. And again, very difficult to manage based on that street gang mentality. This happens in operations all around the globe. And then last thing that these operations miss are the small, we'll call them incremental charges that are missed within the operation. If I have 25 people in my operation and they get 2 breaks a day, they each come back 1 minute late from their break each day, that's about an hour's worth of activity. Over a year, that's a considerable amount. That's about a third of an employee just on missing that. The 3-person meetings where 2 people are trying to solve a problem, then a third person comes in and adds their kind of 2 cents worth. And what happens is these meetings start to steal time and drive the underutilization of time within the operation up. And then lastly, we've all seen it, that one employee that whatever continually happens is they drive the entire length of the building on a forklift with nothing on it. And what we see is this unnecessary travel. Or someone has a gun that, an RF gun that loses its connection, and rather than find somebody on the floor to fix it, they walk and they go all the way back to the manager's office, wait for the manager. And these are aspects where the employee is actually getting rest rather than working because of some external issue. So having benchmarks allows me to identify that inside my operation. So that's why we benchmark. Now, what should we benchmark inside the operation? Lots of things that we can look at. Typically, we have 3 types of functions in the operation. So the direct function, which is anytime we're touching product or we're actually doing productive work. These are typically what we're engaging in industrial standards, industrialized standardization. When you talk about market standards or comparable industry standards and such, because we're measuring these things. On the indirect side, things like counting, maintenance, sanitation, there's really, most companies don't have metrics for this. There's not a really great standard set of metrics in the market. So indirects are much tougher to measure, though many companies treat these as time scenarios or time aspects where they clock in and clock out for doing counting or general maintenance or things like that. And then the last part of the measures would be things like overtime, breaks, sick days, personal days, which we typically would get from our time management system, like a clocking in, clocking out type of system. And we're tracking these through third-party solutions inside of our operation. And so we don't really need to increase or look at those as terms of internal aspect measures. Inside of our measures, inside of our direct touches, we have subcategories and subsets of everything we're doing. Well, if it's in receiving, if it's a full pallet, a composite pallet, we're hand bombing containers, to put away, to picks, to replants, and each one of these have subcategories. Inside of those subcategories, there could be multiple different touch points that we may or may not want to measure. Now, if I'm taking a look at things like industrial engineered standards, we actually build out these subsets through, we'll call them aggregate elements within a particular function. So stepping on a fork, stepping off a fork, aligning the forks, internalizing the instruction set. And there's hundreds of these that are within each one of these tasks. So we're measuring them, and depending on how I'm coming about my measures themselves, sometimes we just do that on averages. We go out and we say, oh, well, typically we're receiving 10 pallets an hour. That's our manager, or that's our measure. When we start talking about productivity, we need to look at the influence factors, and this is all that white noise that goes between operation to operation, operation to the market, shift to shift, based on what they're doing. So depending on what the shifts are doing, there could be things that at each one of these aspects. So am I taking 24 pallets off a trailer, or am I taking 12? You know, is that pallet, does it have 5 layers or does it have 7? Am I lifting off cases of chocolate bars, or am I lifting off cases of brake pads? All of these things affect the aspect of the operation and influence the operation. The number of SKUs in an operation, what we'll call the storage itself. Am I picking off pallets, or am I picking off carton flow? Am I loading into a long trailer, or am I loading into hand bombing onto a side loader or onto my UPS truck? All of these factors are taken into account when you're building up your metrics. So going by saying that, oh, we're loading 25 pallets an hour and all pallets are the same is typically not giving you an accurate look at your own operation. So those measures where we're looking at on the touch point really brings us then to what are the actual ways that we get to our benchmarks? You know, typically we would go to our WMS or our labor tracking system, or if we have an LMS, and we would take a look at each one of the individuals, the activity that they're doing, and come with some sort of performance rate. Now, in this particular individual, they're doing 8.9 hours of work, and their average at whatever it is, 7.51 hours of work time, or 90,000 units in their work period. These are overall measures or aggregate numbers. These don't actually tell me how productive these people are. Now, I could average this over a great period of time, and all that's doing is telling me that on average, this is what we're looking at. Still doesn't tell me whether I'm operationally productive or not, because I'm not working to any standard, I'm working to an average. But this is the typical way that most companies effectively do their benchmarks. They measure themselves against themselves. So if I use the analogy, I'm a long distance runner and I just ran 5 miles today, and I ran that 5 miles in 1 hour and 5 minutes. And tomorrow I ran it at 1 hour and 4.5 minutes. I did great against myself, but that tells me nothing on whether or not I want to be an Olympic athlete, because I would need to know what the minimum time is for that Olympic qualifying, which might be 51 minutes. So if I don't have that actual lower number or the standard, then I don't actually know if I'm doing well or not doing well. How we get to those standards then are 2 schools of thought. Traditionally, when we're building labor standards, we're engaging an engineer and that engineer is doing time and motion studies, and they're calculating down to precision. They're getting down to 1/10 of a percent versus using other models that are accurate. And there's always the dichotomy in the operation. Do I want to be accurate or do I want to be precise? Theoretically, precise is better, but the difference in cost between being precise and getting metrics out there is probably 20 or 30 times more expensive than being accurate. I can manage from accuracy, I can manage from precision. They're both the same if I have a level of accuracy that I'm comfortable with. For the most part, if I went into any operation around the globe and I asked them, how many days of the year do you have that are exactly the same? The answer I'm typically going to get is 0, which means to be precise is really a never-ending return because we'll never get to 100% precision. So creating our standards inside of our operation are used 3 or 4 different methods. Obviously, we have the industry comparison, where someone will say, oh, well, if I'm in grocery, and let's use a Kroger out there, Kroger typically averages 110 cases an hour per individual, per FTE, per hour throughput. And I want to then compare myself to Kroger at 110, even though their buildings are probably 4 times the size of mine, their SKU range is probably double what I have. They're using automation. They're at the top of the food chain when it comes to IT. For me to compare them to 110 units an hour might be a pipe dream, but then again, that's what I'm looking at. The second would be what we call time and motion study. This is where you have an engineer come in and take all of those elements inside of your operation and actually time them over and over and over till they get an average within your operation of each one of these standards. And what happens is this is what is the basis of your typical LMS systems or labor management systems that are out in the market. And those elements, there could be 500, 600 elements that are created inside of this. So that then we become predictive with that time and motion and that type of standard, where it would then say, oh, you have this order, there are these SKUs on that order, and that order should now take you 3 minutes and 14 seconds to pick. And then I could then go back and monitor that and say, oh, you took 3 minutes and 22 seconds. That means you were at 101% or 99% of the standard, depending on how you want to relate that. So that predictive model there is very expensive. It's used in very, very discrete operations. You know, we go to estimations. So based on similar work, similar operations, we go out and say, oh, we think they're about 110 cases an hour. We'll be 110 cases an hour. Let's work to that. You see this a lot in the 3PL market where they compare customer to customer and assume that if I do it for 12, receive at 12 pallets an hour for that customer, I should probably do it for this customer as well. And so that's that estimation. And then the last model is what we call synthesis or synthetic building of the standards. And again, these standards are using a formula, using really predictive or presumptive analysis to create standards. Think of it this way. I'm sure everybody's out there used something like Google Maps or a GPS system. And if you're driving, say, from New York to Chicago, it's going to tell you that's around 800 miles, and it should take you 12 hours and 15 minutes. And you measure that, and essentially what you end up doing is you drive, and if you're like me, I'm actually watching that clock all along to see whether or not I'm making that standard of 12 hours and 15 minutes. And that what that does is that takes the distance, it takes the average travel speed based on the speed limit. Nowadays, they're getting even more accurate with it as they say, oh, there's a backup in this area and it's an 8-minute delay. And that's a synthetic model of building out your travel. And we can do that same thing inside of the warehouse. So we can look at all of the things that we can build up for these synthetic models. The difference would be that the synthetic model is what we would call accurate and presumptive versus your time and motion study, which is predictive and precise. Obviously, the synthetic model is going to be a much more rapid model of creating your standards rather than doing the precise model, which is why we all love Google Maps, because the minute I put in my directions, it's telling me how long it's going to take. I get that almost instantaneously based on 3 or 4 key inputs. So I told you all that so that I could talk about our DC Expert. Our DC Expert is really the only synthetic model out there on the market today that looks at building your KPIs. Now, if we go back and look at all of those aspects that we've talked about up until this point, building an accurate model that's presumptive using, we'll call it elemental data and databases picked up to calculate your KPIs inside of an operation. What we end up doing is we take the noise out of, we'll call it the industrial measurements. So our software itself is building up about 22 key aspects or KPIs inside the operation using 72 fields of data. But out of that 72 fields of data, only 17 are mandatory. And we've measured this against those predictive solutions, the labor management solutions out there. And our software and our presumptive models are within 2% of those predictive solutions. So again, directionally accurate without the cost. It's management friendly. You could run this daily. You could run it shift by shift, operation to operation, week to week. It really doesn't matter. And it's an easy model to help you drive out your savings inside your operation. So what it'll help you do is find out what areas of my operation am I underperforming in. How do we do this? We have 5 key databases. So we have databases based on the MHE equipment we have, liftoff speeds, accelerations, decelerations, basically those speed limits that we have in our Google Maps. We have all the work constraints or all those human constants that we have in there. And what we've done is we've taken a database from 3 different categories, or 3 different geographical models, one from Asia, one from Europe, and one from North America, and we've averaged those times out. So if we talk about stepping on a fork, in Asia, it might be 1.6 seconds. In Europe, it might be 1.7. In North America, it's 1.55, and we're using 1.62 as the average. And what we've got is we've got over 700 of these constants that we're using in there. Then we have a database of skew characteristics, heights, weights, and cubes. So again, if I'm doing solo cups, I can only carry 1 box, even though it weighs 1 pound. But if I'm carrying boxes of chocolate bars, I might be able to do 4 or 5 and pick up 4 or 5 when I'm loading them at one time. We have the entire personal fatigue models based on general industrial standards on those fatigue curves. And then lastly, we layer on top of that a temperature database and how that affects personal fatigue. So that again, if we've gone to an operation that's set their KPI, say down in Atlanta in July, and now I'm measuring another operation in the same network up in, say, upper state New York in November, well, if I didn't take temperature into consideration of that, the warehouse might have a temperature of 55 degrees up in November, but when they set the standards down in Atlanta, when the temperature was about 88 degrees in the warehouse, I'm giving those people in the northern state a 3% advantage right off the bat just because of the temperature band. So we want to take all that and build all that differentials from operation to operation into a very usable, easy and usable operational data set. We take into consideration the types of travel that you have inside the business. So we have what's called travel direct. That's where you have a straight direction of travel or start and stop. So put away, replan, full pallet picks, things like that, where there's only travel direct versus what we call perambulation. This would be when you're inside the storage medium. So you start and stop, you turn, all of these things are taken into consideration because now that's not only a function of how many starts and stops you have, but it's also the acceleration, deceleration, the turning speeds, the turning radius of all the equipment. And what we do is we factor all of that in to the operation. So here's a perfect example of how the measures that we get out of DC Expert can show a differential in the same operation in a very short period of time. So highlighting this operation, you could build this out with our model, but essentially take a look at all types of activity inside the operation. And in this particular case, in first month, we're doing 3.8 million units. And then in the month 3, we're doing 3.66 million. But because of the differentials within the operation, week to week, we have a SKU mix from almost 213 different SKUs in the operation from week to week or month to month. We start looking at the overall percentage. When we put all this together, it's the same operation, but in the first month of this sample set, they were at 76% of the work standard. We haven't changed anything in 2 months later, except the way the activity is going, but we find that we're at a much lower work standard. This would be on the fact that there's maybe more overtime, that their orders weren't coming in on time, that there was a lot of underutilized time within that month. So what I'm seeing is the same operation has a differential of 6% from 1 month to the other. Now, 6% in an operation of this size is very expensive. That's probably the difference of 10 or 12 full-time employees or at full-time equivalents within 1 month. So being able to build up models like this in a very, very short period of time allows you then to manage out your overhead within the operation. We could take a look at this layering model. If we take an A SKU to an A client and we manage that, we could see that within the operation, it's costing me 6 cents. But if I take a C SKU to a C operation or a C customer, it's costing me $1.20. I could look at these factors if I have, say, an 80-20 rule versus if I have a 90-10 rule inside my business. A 90-10 rule means that this is going to be far more punitive than, say, to an 80-20. If it's 50-50, then I'm looking at my profitability, that anything above sort of this line from A to A is all profit, B and C's are we'll call it my underutilized time. So what I thought I would do is, we're running around about a half hour here, is really just pop in and give you a quick overview of how the software works. So if I just do that and I pop out here. So again, we talked about our software, that there's 78 fields of data. If it's yellow, it's a mandatory model. So what we're looking at here is an operation that's being calibrated at 78% of the work standard. We're looking at 160 hours of work time, which is actually the equivalent of a 1-month data set. We're using an imperial measure here, and the current operation is calibrated to 157 cases per hour per head count. Because of the operation, the way we set it up, there's 137 head count in the building, or conversion to head count, or 22,000 paid hours in the operation. The operation is picking 1.3 million cases. 2.1 million cases are full pallet picks. There's 867 SKUs, 36,000 orders. We get a sample set of the order lines, how the pallets are coming in, what our Pareto is. But typically we look at the averages inside the operation. So again, these measures that we look at, how many pallets are on an inbound vehicle? How many pallets are on an outbound vehicle? Are we skimming? Are we hand bombing? Do we have a one-way replen? Do we have a two-way replen? All of these things, how are we checking? How much are we checking? The size of my operation. So it's about 600,000 square feet and such. And my distance between SKUs, I'm picking off a pallet, so it's 4 feet between SKUs. Am I using IT, so a WMS, to actually do things that dual cycling that allow me to interleave tasks in the operation? And then what type of MHE do I have? So again, we're looking at MHE as an overall model. So we're not considering whether it's gas, electric, or natural gas. We don't care who the manufacturer is and what the acceleration speeds are. We're basically using step curves on all of this type of data set inside of the MHE tabs. Once I've done all this, I've entered in my data. all I have to do is calculate that, and I get 3 reports. Now, based on my activity profile, I can see how many pallets I'm receiving, what I'm picking, what I'm replanting, what I'm putting away. But I also get a Pareto analysis based on my curve on my SKUs as well as my orders. Very important for us to look at what an A order looks like versus what a C order looks like. Then based on my 78% of the work standard, the size of the building, all of those factors that we've created, I've then calculated using my synthetic model what my KPIs are inside the operation. So 31 pallets an hour receiving, 12 pallets an hour on put away. And we get down to our picking. We have full pallet picks and full case picks. We have a model that says a blended number of 90 cases an hour and such. And then we look at all of our other variables, checking, loading, shrink wrapping, and such. Then what we do is we combine the reports to get what we call a summary report that tells me what the KPI is, what the rate is per hour, the total number of units, and then calculated the number of hours of work inside the building. So we know that it's 976 hours a month. That calibrates to 6.1 people. And then you as the operator come back and tell me, well, that's not right. I've got 9 guys in receiving. And if we go down, say, to picking, well, picking says that you require 100 people. And as the operator, you bump your chest and you say, well, that's not right. I've got 95 guys that are in picking, and that's my head count. And essentially, no matter where we go around the world, we whip our pickers. We measure them. We measure everything those pickers do because that represents about 50% of my labor. Everybody else falls below the radar, but we measure the pickers. So then I go back and I can look and say, inside of my model here, if we're at 78% of the work standard, my guys in receiving are working at a considerably lower work standard than, say, those guys in picking. So picking might be working at 82 or 83% of the standard or the calculated standard versus the receivers that are maybe working at 60%. And I can use the tool a number of ways. I could come back and say, well, what is the net effect of, we're not going to change any of the activity, but let's say I add 200 SKUs into the operation. And that's all I'm going to do. We're not changing any design or anything. We're just adding a couple SKUs in the building. Well, we go from 157 cases an hour. I recalculate this. I go back to my model and I go to 146 just because I've added more SKUs. Most companies won't take that into consideration. At that rate, I've just added 11 people into my operation. Now I might go in and say, okay, but you know what? I'm going to go and I'm going to add carton flow to a small part of my business, which is going to basically bring my travel down or my distance between SKUs down by about 10%. All I have to do then is I can calculate that. And now that 138 people, based on that new travel parameter, okay, goes from 148 down to 142. So I save 6 people. So now I can be predictive with what's going. And then if I go back to my summary report, I changed my picking. I didn't change anything else. So my guys in receiving are still at 6.1. But if I go down to picking, okay, I've changed my model. I've added more SKUs, but I've put in some carton flow. So I'm only adding 5 people instead of 15. So I can look at all of these factors and put them into my sample set. So once I've created the standard, I can use this as a predictive model to say, what if? What happens if my activity goes up or down and such? You could also look at this operation and say, well, I don't like the fact that we're at 78% of the work standard. I would like my business to be operating at 85% of the work standard. So at 85% of the work standard with my operation, as that I've just got in the data set here, instead of 152 cases per hour throughput, and I recalculate that, I could then go back to this and I should be at 165. So that maybe then is my Olympic minimum target that I would like to look at inside of the operation based on this activity profile right here. If something changes in that, we add more SKUs to the order. So now I have 13 lines per order. Okay, and maybe I only do 35,000 orders. What comes back is, again, I'm going back, my rate might change slightly because of my order profile, but I didn't change my performance. You can look at your hours, your people, and say, oh, I need less people. I went from 142 to 129 because I have less activity. So this is how we use the synthetic model to create our benchmark and our studies. So that's kind of an overview of the software. And it's an overview of how we use labor benchmarking to drive out savings inside the business. It's very tough if I don't have a standard to set to actually drive any cost savings out because we don't really know what to expect. So creating the standard up front and then being able to modify that, saying that if I reslot it, I put in carton flow, or I buy an ASRS, or I use robots for picking or put away, or some sort of AVG. All of these things could be modeled inside the software to see how it will drive labor out. And that's an overview of the system. If there are any questions out there that we can see? So at this point, what we'll do is we've been recording the session. We'll put it up in an area where you can review this if you want. Everybody that's attended today will also get a copy of the presentation. And what we'll do is we'll also, when we send out that copy of presentation, send you out a little bit of information on the benchmark tool. Once again, everybody, thank you for your time. We know it's valuable, and we're more than happy to answer any questions after the fact if you have any. Once again, thanks everyone, and have a great day.